All right, hi everyone, welcome back to chemistry. In this video, we're going to continue talking about electron configurations. I got cut off in the last video, so sorry for the abrupt ending, but I had a couple more things to say. So in your textbook, there's a whole section that talks about some kind of exceptions to the rules. And in chemistry, there are often some exceptions to most rules. And it's just because nature is not completely symmetrical all the time, right? So one of the kind of exceptions, or maybe things that wouldn't be so, obvious, is that for electron configurations for period 4 and higher, so 4, 5, 6, 7, the order that the sublevels are filled, or that those orbitals are filled, is a little bit different. So for sublevel blocks in period 4, the 4s sublevel actually fills before the 3d sublevel. And that's just because the 3d sublevel is slightly higher in energy than the 4s sublevel. We also see this with the 5s sublevel, which fills before the 4d, and the 6s sublevel, which fills before the 5d. So if you look at the periodic table, you can kind of see here, because they've actually written these numbers here, but on most periodic tables, those won't be there. Okay, so when you're labeling this is period 1, period 2, period 3, period 4, period 5, period 6, period 7. So what you'll notice is that this is period 3, but there's a little kind of step down here, and this is still 3D instead of, sorry, I should point to it. This is 3D instead of 4D, even though it's in that row. And that's to indicate the that change in the way that those sublevels are filled. So when we fill those electrons, they're going to actually fill this sublevel first, the 4s2, and then they'll keep going and fill the 3d10, okay? So I know it's kind of weird, but I just kind of like to think of it as like a little stair step down, because you'll notice this is 3s, 3d, 4s, 4d, right? So I don't know if that helps or not, but yeah, just remember that these aren't always going to be there, okay? Okay, so now that we've done some of those exceptions, there are some other exceptions in order filling, and you don't need to memorize them. In some chemistry classes, they like you to at least memorize copper, the fact that, or just be aware of the fact that with copper, look at this part right here, and you'll notice that that 4s, sorry, let me highlight that differently there. That 4s sublevel is not filled, right? Remember we said that the max is 2 electrons per s subshell, or s orbital, and it's not actually filled. And the reason is because the electrons actually populate the 3d10, even though I just said that they populate 4s first and then 3d10. This is one of those rare exceptions where it's actually more stable for this particular element, copper, to have 10, which is a full 10 electrons in the 3d sublevel, than having the 2 over here first. Okay, so in many other circumstances, they're going to fill that 4s2 first, okay? And then the 3D, but this one's just one of those weird exceptions, okay? Likewise, chromium does the same kind of idea, although it has a half-filled D sublevel, okay? So some exceptions to be aware of, but I'm not going to like try to trick you and throw these on an exam without, without mentioning it. But you might need to be aware of that in the future for other classes, okay? especially for copper, since copper is actually an element that we do work with a lot in lab. I don't like this example, but I wanted to leave it in here so I could remind myself to do a different example. So let's do an example from your textbook, which is looking at silicon. And silicon is, if you look at your periodic table, silicon is in the third period of the periodic table. So have that periodic table in front of you. So our goal is, and let me actually look at the periodic table up here. So our goal is to write the electron configuration for silicon, which is right here. Whoops. Oops. For silicon, which is right here. So pause the video, try it out. What I want you to do is draw the orbital diagram and give me the electron configuration. Okay, so let's actually write that here. Draw the orbital diagram for silicon. And then draw, or I'm sorry, we would say write, write the electron configuration for silicon. I apologize if my pen is driving you crazy. And then finally, I also want you to write the noble gas configuration. I'm just going to abbreviate that config for silicon. Okay, so this is the first one I want you to do. This is number 2 and number 3. Okay, pause the video, try it out. Okay, so for silicon, what is silicon's atomic number? Yeah, 14. So let's make a note. Atomic number 14, which means it has how many electrons? Yeah, 14. Okay, so this is going to be a little bit longer than the other ones we've done, but we can do it. So what's the first sub-level? Yeah, 1s. So I'm going to draw my boxes here. And you know what? I'm actually going to draw them a little bit bigger so that we can see it better. Okay, so here's my 1s. What's this next box that I've drawn? Is it a 1p? No 1p exists, right? Just 1s. Okay, so I have my 1s. Now I go on to my 2s, right? What comes next? Yeah, 3 of my 2p's. So 2p, let's just go ahead and label them 2px, 2py, and 2pz. Remember that those x, y, and z's there are to show what axis they lie on. I'm just doing it so that you can see the 3 different p orbitals. That's why I'm labeling it like that. Okay? And that's something that you'll see and be expected to do in the future. Okay, so 1s, 2s, 2px, 2py, 2pz, and then let's just think here for a second. If silicon is in period 3, we fill, right? We fill these two, the 1s2, we fill the 2s2, we fill the 2p6, and we get to 3s2. We also fill that. So let's go ahead and do that. So we know we get through 3s as well. And then we're still in the third period, so let's put our 3p's, 3px, 3py, and 3pz. I'm okay if you don't want to put the x, y, z on there, that's fine. But you do need to write that you know it's a 2p or 3p. Okay, so you could have written this like this as well, and I'll get what you mean. You could have also written it like this, or you could write it with the x's, y's, and z's. Okay, I'm going to write it with the x, y, z just because I know what they're called, so we'll just be as specific as possible. Okay, so I think that's all the boxes I need, right? Do I get to the 4s? No, I don't quite get there yet, right? I'm only in my p's. So let's go ahead and fill this out. So I'm going to use a different color. How many electrons do we have? We have 14. So 1 and 2. I'm going to populate the lowest energy levels first. Make that a little bigger. Sorry. Populate the lowest energy levels first. So I have one spin up and one spin down, one spin up and one spin down. And I know I fill all of my P's. So 1, 2, 3, 4, 5, and 6. So now I have 10 total electrons. And now I'm going to go 1 and 2 for my 3s, because I fill that next. And then I fill my 3 P's. How many electrons do we have left? This is a total of what? 12. So I need 2 more, right? So are they going to pair up like this, both in the px? 3px? No, no. Remember our bus analogy. They don't want to pair up yet, unless they have to. So we're going to put it in a 3py. Silicon is not one of those couple exceptions that we talked about, so it's just going to fill like normal, okay? All right, so that would be the orbital diagram for silicon. Yeah, pretty cool. You could have also drawn your arrows like this. That's totally fine. Okay, either way. Okay, so let's go ahead and write our... Sorry, I'm trying to figure out, that was obnoxious, huh? I'm trying to figure out what color I want to use. So I guess I'll use blue. So write the electron configuration. So now we want to write all of this in a shorthand form. So how do we do that? Well, just like I say it as I'm going across the periodic table, where I'm like, oh, I fill my 1s2, I fill my 2s2, I fill my 2p6. I'm going to basically write that down here. So 1s2, right? That's this here. 2s2, that's this here. 2p what? Is it 2? Nope. 2p6, right? And then 3s what? 3s2, because there's 2 electrons in there. And then 3p what? Sorry, that's a lowercase p. 3p2, yeah, I don't get all my 6 here, okay? So just 2 of them are filled. And that's, you'll see, that's actually saying the same thing as the orbital diagram you've drawn out. Okay, so great. So let me draw a little box around that. Okay, so now we want to write the noble gas configuration for silicon. So let's go up here. What noble gas have we filled for silicon? Like what noble gas comes before silicon that we have actually filled, that we could replace those that part of the electron configuration with? Is it argon or neon? Yeah, neon. Because argon, we're not there yet, right? We haven't gotten there yet. Okay, so we're going to use neon. So what's neon's noble gas configuration? Well, neon is right here in the P block, and it's in energy level 2, and we've filled this electron, this electron, this electron, this electron, and this electron, and this electron, right? We're in that sixth electron spot. So we could say 1s1, 2s2, and 2p6. That's all neon. So let's go ahead and write that. That's neon. So we're going to write it down here as Ne with those brackets around it. And then if we have to keep filling in, we fill in the rest that's left over. So everything that's left over here. Sorry, let me do that in a different color. We got to fill in the rest of that stuff here. So that's going to be 3s2 and 3p2. Okay, so now what you can do is you can see how many electrons are actually in your highest energy level, right? I'm in my highest energy level, which is 3 for this element, silicon. And I can see very clearly now that I have my noble gas configuration done, that I have 4 electrons in my highest energy level. I don't know. I think it's really cool. So I hope that helps. Let's keep moving along here.